Have you ever just stared at a map and noticed those beautiful curved chains of islands, like Japan or the Philippines? And have you ever wondered how in the world did those get there? Well, today we're going to dive deep, and I mean that literally, to get to the bottom of the powerful geological forces that build these incredible island arcs. So, let's get into it. First, I want you to just picture this scene. Far, far beneath the waves, in absolute darkness, you have these two colossal pieces of the Earth's crust. We're talking continent-sized plates, and they are on a collision course. It's this super slow-motion crash that's been going on for millions of years, and it's the engine behind some of the most dramatic features on our entire planet. So, what actually happens during the slow ocean crash? Let's break down that very first part, the simple ocean collision. Now, this isn't like a head-on crash between two cars. It's different. Instead, one of the oceanic plates, and it's usually the one that's older, colder, and because of that, heavier, it gets forced to bend and dive deep, deep down into the Earth's mantle. It sinks right underneath the other, lighter plate. And this whole process, it has a name. It's called subduction. And honestly, this is the one word you really need to remember. Subduction. This fundamental action of one plate sinking beneath another is the key that unlocks the entire mystery of how these island arcs are born. All right, so we've got one plate diving under another one. But how does that underwater action lead to islands that we can actually see and, live on? Well, let's look at the recipe. It really all boils down to three pretty simple steps. First, you've got the collision, which we just talked about. The second step, melting. You see, as that sinking plate plunges deeper, all the immense heat and pressure squeeze water out of its rocks. And here's where the magic happens. That water lowers the melting point of the super hot mantle rock above it, causing it to turn into magma. And that leads us right to our final step, formation. This new magma is way less dense than the rock around it, so it starts this slow but unstoppable journey upward. Eventually, it erupts right onto the ocean floor. And over millions and millions of years, eruption after eruption builds a massive undersea volcano that finally breaks the surface of the water, creating an island. Okay, but you might be thinking, if it's just a line of volcanoes, why do they form that really distinct, elegant curve that we see on a globe? Why isn't it just a straight line? That's a great question, and there's a really simple reason for it. And here is the answer. The arc shape is just a simple consequence of geometry. It's what happens when you try to lay something flat on a sphere. I mean, think about it. Try to wrap a flat piece of paper around a basketball. It naturally has to create a curve, right? Well, it's the exact same principle, just happening on a massive planetary scale. So now let's connect this whole process to the real world, because these volcanic chains create one of the most active and, one of the most dangerous regions on our entire planet. When we talk about island arcs, we're talking about places you definitely know. We're talking about Japan. We're talking about the Aleutian Islands that stretch out from Alaska, the Philippines. These are all classic examples, and they all have one major thing in common. They're a huge part of the massive Pacific Ring of Fire. And because these island arcs are sitting right on top of these incredibly active subduction zones, they are absolute hotspots for natural disasters. I mean, all that constant grinding, melting, and shifting of the plates, it means these areas get a lot of volcanic eruptions, some really powerful earthquakes, and, as a direct result, some devastating tsunamis. It's kind of the price you pay for living on land that's been created by such a powerful process. So, as we start to wrap this up, let's just bring it all together. You can really think of this entire process as a huge, hidden battle that's happening miles and miles beneath the ocean's surface. So if you remember just one thing from all of this, let it be this simple idea right here. An island arc forms when one ocean plate subducts, or dives, under another one. That action causes rock to melt, which creates magma. And that magma then rises to form a curved chain of volcanic islands. That's it. That's the whole story. And I want to leave you with this last thought. These beautiful island chains, they aren't just land on a map. They are the visible scars, and maybe even the trophies, of an epic, ongoing war between tectonic plates. They're a powerful reminder that the very ground beneath our feet is the product of unbelievable fire and pressure, a surface expression of a hidden battle happening deep, deep beneath the ocean.